Welcome to Academic Guru's Tutoring Thursday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Thursday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos.
Alright, so today I'll be solving 3 questions that was sent in by Jessica. So the first 2 questions are related to integrals, and without further ado, let's tackle the first problem. So we have to integrate sine of theta plus sine of theta times tangent squared of theta, all this being divided by secant squared of theta. Now, this might look like a pretty complicated integral, but as I've always said in the past, whenever you're dealing with integrals that involve some sort of a trigonometry, you've got to start to remember your trig identities, because they're going to help you significantly when dealing with these kinds of integrals. So the first thing that I would do in this case is to factor out the numerator and then just take it from there. So we're going to have our integral sign again, and then we're going to factor out the sign, so it's going to be sine theta, and then from here we're going to get 1 plus tangent square of theta, all of this being divided by secant squared of theta. Alright, and now from here, that's where you're going to start recalling your trig identities. But since we have a lot of trig identities, I don't always tell my students to remember all these formulas, because it can get pretty complicated. So what I would do is, I would just tell my students to remember the fundamental formula, which is sine squared of theta plus cosine squared of theta equals 1. And then from there you can pretty much derive all the rest of the formulas. So let me pick a different Sharpie here. So we're gonna have sine squared of theta plus cosine squared of theta equals 1, and then if I divide everything by cosine squared theta, then so for this, so sine squared of theta divided by cosine squared of theta, that's simply going to be tangent square. So I'm going to have tangent square cosine squared of theta divided by cosine squared of theta, that's just going to be 1. And then here I'm going to have 1 over cosine squared of theta, that's going to be secant squared of theta. So we just derived this new formula from our fundamental formula. So we're going to have secant squared of theta. And that's essentially all we need for this problem. Because if you take a look here, we have 1 plus tangent square, and then we just figured that out. So 1, it's going to be the same, they're just interchanging tangent and 1, but it's not going to make a difference since we're adding them together. So tangent squared of theta plus 1 is simply going to be secant square. So I'm going to make a big change to my integral now. So I'm going to have, let's see, here, let me make this. Okay, so it's going to be integral, and then we're going to have sine of theta times secant squared of theta divided by secant squared of theta. And then we're going to simplify, so secant squared and secant squared divide out, and we're going to be left with integral of sine of theta, and from here we're just going to get negative cosine of theta, and then of course we're going to have our constant, so it's going to be plus c. And there is your antiderivative. So what seemed to be a pretty complicated integral, now it's all narrowed down to a simple answer. Always remember to recall your trig identities when dealing with these kinds of problems, because they really help you streamline the integration process. Again, you shouldn't remember all the identities, but I would highly recommend that you remember the fundamental formulas, because frankly you can derive all your alternative identities from the main formula. So there you have it for this first question. I'll solve the second question shortly. So let's take a look at the second problem. Again, we have to integrate x plus 1 times x squared plus 3. In situations like this, I would just multiply everything out, and then if I have any like terms, I would combine them together, and that's exactly what I'm going to do with this problem. So x times x squared is simply going to be x cubed, so I'm going to have x cubed plus 3 times x, it's going to give me 3x, and then 1 times x squared is just going to give me x squared, so I'm going to have x squared, and 1 times 3 is simply going to be 3. And then I would just take the antiderivative of each piece individually. So for our first term, x3, it's going to be x fourth, we're going to add 1, and then we're going to divide it by the new power, so it's going to be x to the fourth power divided by 4. For the next one, we're going to have 3x squared divided by 2. Antiderivative of x squared is simply going to be x cubed divided by 3. And for our last term, antiderivative of 3 is simply going to be 3x. And now we're just going to tack on our constant. So there you have it for this problem. Alright, so for the third problem, we're going to solve for a logarithmic equation.
Thank you for tuning into our Tutoring Thursday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Thursday, happy studying.